Okay students, so in this class let us solve some problems from the model question paper. So look at the first question. We have to find the directional derivative of the function phi at the point 1 minus 2 minus 1 along the direction 2i minus j minus 2k. Okay, so let us solve this. First let us write the given thing. What is the given thing here? So phi equals to, it is x square yz plus 4xz square. Okay, so we all know the directional derivative of the scalar function phi. So in the direction of a vector a, so that is equal to the gradient of a phi into the unit vector. What is that unit vector? It is the gradient of phi into the vector a divided by its norm. Right? Okay. So here in this question, first we have to calculate the gradient of phi. So to calculate the gradient, so I need to calculate the partial derivative of this. So let us calculate the partial derivative of phi with respect to x. So what is that? It is a dou by dou x of x square yz plus 4x square z. Let us denote that by pi x. Pi x means dou pi by dou x. That is equal to what? Here y, and we are doing a partial differentiation with respect to x. So y and z are constant here. So here 4 is constant, z square is constant. So what happens? So let us write the constant term first, and let us differentiate x square, that is 2x plus, here the constant term is 4z square, and the differentiation of x with respect to x is 1. So finally it is 2x yz plus 4z square. Okay, yeah. So let us calculate the partial differentiation of phi with respect to y. So that is dou by dou y of it is x square yz plus 4xz square. So we are doing partial differentiation with respect to y. So x and z are constant. X is constant, z is constant, here 4 is constant and z is constant, and x is also constant here. So let us write the constant term first. It is x square into z, that if partial differentiation of y with respect to y is 1, plus here here 4xz square are constant, the differentiation of constant function is 0. So it is x square into z. Right? So now we have to calculate the partial differentiation of phi with respect to z. So that is equal to dou by dou z of x square yz plus 4xz square. So here x and y are constant, here 4x is constant. We are doing partial differentiation with respect to z. So first write the constant terms. So x square y is constant, the partial differentiation of z with respect to itself is 1, plus 4x is constant, the partial differentiation of z square is 2z. Now it is equal to, so x square into y plus 8xz. Right? So now let us calculate the gradient of phi. What is that? It is I into dou phi by dou x plus j into dou phi by dou y plus k into dou phi by dou z. So this is the formula. So this is equal to, so I into, what is dou phi by dou x? It is 2x yz plus 4z square plus j into, what is phi y? It is x square z plus k into what is dou phi by dou z? It is x square y plus 8xz. Right? So now we have to calculate the partial differentiation, we calculated the gradient. Now we have to calculate at this point 1 minus 2 minus 1, we have to calculate the gradient. Now the gradient of phi at, what is the point? It is 1 minus 2 minus 1. At 1 minus 2 minus 1. That means we have to substitute x equal to 1, y equals to minus 2 and z equals to minus 1. So here I into, so here x, y, z, we need to multiply these three elements into 2. So 2 ones are 2. So 2 into minus 2, minus 4. Minus 4 into minus 1, plus 4. Plus z square, minus 1 whole square is plus 1. So 1 into 4 is 4. Plus j into, so x square, 1 square is 1 and z square, x square is 1 square and z is minus 1. So it is minus 1 into k, right? Minus 1 into j, right? So plus x square, 1 square is 1, y is minus 2, so minus 2, plus 8 into x into z, so 1 into minus 1, it is minus 1, it is minus 8 into k. So on simplification, it is 8i minus j and minus 2 minus 8 minus 10k, right? Fine. So now what is the given vector here? The given vector is 2i minus I minus 2k. So what is the given thing here? Let me call that as a, that is equal to, so 2 into I minus j minus 2k. 2 into I minus j minus 2k, right? So first let us calculate the magnitude of this. It is, the magnitude of this is equal to square root of, what is the coefficient of I? 2. So write 2 square, right? Plus coefficient of j minus 1, minus 1 square, plus the coefficient of k minus 2, minus 2 whole square. So that is equal to, so square root of 2 square is 4, minus 1 square is 1, minus 2 square is 4, which is square root of 9, which is equal to 3. So now what is the unit vector? That is equal to the vector A divided by its norm. Okay, so the vector A is 2 into I minus j minus 2k and the norm is 3. Okay, so now we can calculate the directional derivative. We can calculate the directional derivative of the scalar function phi in the direction of the vector A, that is equal to what? The gradient of phi into A cap, right? Okay, so we know the gradient here. So what is the gradient here? The gradient is given by, so the gradient 8i minus j minus 10k. We calculated the gradient at the point 1 minus 2 minus 1, right? So we are also calculating the directional derivative of phi in the direction of the vector A at the point 1 minus 2 minus 1 into the A cap. A cap is 1 by 3 into, so 2 into I minus j minus 2k, right? Fine. So let me take this 1 by 3 outside and let us multiply the coefficient of I. I'm doing the vector multiplication, right? So 8 2s are 16, okay, plus coefficient of j is minus 1. Here the coefficient of j is minus 1, minus 1 into minus 1 plus 1, plus the coefficient of k is minus 10, the coefficient of k is minus 2. So minus 10 into minus 2 is 20. So what is this? This is the 16, 20, 36, 37. So 37 by 3. So this is the directional derivative of This is the directional derivative of the scalar function phi to the point 1 minus 2 minus 1 along 2i minus j minus 2k. Thank you.